Welcome everyone to this second webinar, which is a preparatory webinar for the CASSINI Hackathon, which takes place at Space Campus in Noordwijk on 24th till 26th of April. And today we will elaborate a bit on one of the main challenges. But before we dive into the content, let me explain a bit about the agenda for today. So, my name is Martijn Seijger. I will be your host today and the host for the hackathon. Then we have quite a lot of speakers. Speakers from NVWA, from S&T, from the Ministry of Infrastructure, and from Rijkswaterstaat. They all present a case which is relevant for the hackathon. So two bit more elaborate presentations and two shorter one. And if there are any participants who want to pitch, so take the 1 minute of fame, there's an opportunity to do this after all the presentations of the speakers. So please put it in the chat so we can pick an order then and facilitate your pitch. My colleague will take care of this. Then the Dutch partnership for organizing the CASSINI Hackathon has many organizations. So it's organizations from the industry, from the public domain, and also the municipalities and the regions, and also of course the Netherlands Space Agency is also involved in this hackathon. So feel free to learn more about these organizations. And also learn about hackathons by following the URL, which reminds me that the slides will be shared right after this presentation. So now a bit more about the CASSINI Entrepreneurship Initiative. So the hackathon is only one element of this entrepreneurship initiative, and the CASSINI program supports startups, SMEs, to develop solutions that use space technology. Can be Earth observation data, can be technology, could be navigation, technology for navigation, and also for satellite communication. So it offers not only startup mentoring, but also it has idea competitions and other investment programs. So the CASSINI Hackathons is one of the core elements of the CASSINI program, and especially creating an ideation platform. However, it's not only about the ideation, but it's also about stimulating the development of solutions and of space technologies. So all part of the CASSINI program. So this hackathon, Space Technology in Water, has three main challenges. Challenge one is securing equitable and efficient access to water, which we will highlight a bit in the next webinar. Then we have challenge two, tracking and preventing water pollution, which will be the main aim of today's webinar. And then we have the challenge disaster risk monitoring, and some nice examples were given in the webinar of last week, which you can watch, of course, via YouTube. Of course, all these challenges are quite broadly defined, and today we will give you some insights in topics where you can think on, and even better, where you can work on during the hackathon. So we'll provide you the challenges in this second main challenge presented by the topic owners. So the hackathon will take place at the Space Campus in Noordwijk, and it is an on-site event only. So be aware that your team has to be on-site. The registration deadline is the 19th of April at noon. So please invite your teams and other people who have an interest to secure their spot before this deadline. And for those who don't live in the vicinity and neighborhood of the Comet Lab, we can provide some accommodation, but you have to let us know in advance. a bit of the program highlights then. So we welcome you at 4 o'clock on Friday. Then at 5 o'clock, we have the local kickoff. At 6 o'clock, there's the official EU kickoff. And then the floor is literally all yours. So the building is open from 8 o'clock in the morning till midnight. And then on the Sunday, you have the opportunity to hack until 3 o'clock. Then all prototypes, presentations has to be delivered on the Taikai platform, and then presentations will take place. And at about 6 o'clock, the local winner will be announced. So during the days, there will be all kinds of events in terms of workshops, which will be live streamed and are accessible via the Discord channel. So what happens after the hack? After the hack, at the 29th of April, there is the EU Demo Day. So all local winners will be pitching in front of a jury, and then the winner of this local winners will be awarded with 100 mentor hours from EU experts. Of course, we have some rewards if you win the local competition. After the hackathon, we will do outreach to all the participants because to tell them more about the follow-up program which we have in mind. Because on the 1st to the 3rd of October, we will organize a second hackathon regarding the domain space technology and water. And then we focus a bit more on higher tier levels like 4 or 5. And the output of the Feeders hackathon is linked to a funding program, to a support program, which you then can apply for. And it might it might give you access to another EU network and support program. But not only the EU programs we focus on, especially local involvement with this is also part of this program. So the 2 hackathons, including the mentoring between those hackathons. Then I would like to ask you to put already in your calendar to save the date on the 28th of May, because then we will organize another workshop on satellite data applications, and this will also take place on the Space Campus in Comet Lab. So this is all I had to say. In case of any questions, feel free to speak up, or otherwise put them in the chat. And yep, go ahead.
Yeah, maybe we should remind to participants that the winning team will also have an opportunity to pitch their project at Network and Drinks in plant that is hosted by Space Campus on 30 April.
Yeah. So we provide, as part of the local award package, pitching opportunities and collaboration opportunities. And of course, we have some monetary awards. So thanks. So without losing time, now we're really at schedule, which is a unique event in my opinion. I will give the floor to Dakshin, who will present the first use case. So Dakshin, the floor is yours.
Awesome, thank you. Let me just share my screen. Yeah, hi. So my name is Dakshin. I work at NVWA at the Innovation Laboratory, one of the largest enforcement agencies in the Netherlands, and our department focuses on constructing innovative solutions. And from the Innovation Laboratory, we have a special team working on electronic monitoring systems on ships. Maybe a quick background sort of information for you guys. EM is sort of trending right now. EM is electronic monitoring. It is a concept of having cameras on board vessels so that you could have compliance monitoring, maybe even inform fisheries and sustainable fisheries management. This is to curb illegal, unreported, and unregulated fishing. Through that project which we are working on, we've decided to pitch an idea that a sort of challenge that we are facing, and we thought maybe this is a good pitch for the hackathon, and that is space-enabled detection of discards on fishing vessels. So yeah, as I was saying, fisheries, again, is super important all around the world. Again, it is important in terms of food security, livelihood, culture, traditions. In the Netherlands as well, it is super economically important and very closely linked to all of the marine ecosystems as well as the EU market. And a lot of economic drives happen through fisheries. But again, with such a big change in fisheries, it has started pushing towards overfishing and IUU activities as well. So these are some of the problems that the fishing sector is facing. And the other set of issues are also discards and bycatch at sea. So there are cases where the fishermen would catch a bunch of fish and then decide this is not what they want and throw it back out, and then go out again, fish, and then catch exactly what they want. Or, for example, let's say they're supposed to catch 10 and they probably catch 20, and they're just going to release 10 from their quota to make sure they hit it. So these are some of the issues that are happening in this entire field. And to also add to this, we have an EU policy at the moment, which is the landing obligation, which means that whatever you catch has to be reported, and that is not entirely done. Again, to add to that, we also have a new legislation which states that all EU vessels have to have cameras on board, and this should be done by Jan 2028. So time is of the essence right now. We're sort of running short. So in that context, we find that discards is one of the biggest problems and something that we're going to be focusing on, because there has been a ton of fish that has been discarded despite landing obligations. People have found a way to move around this landing obligation. And this happens because inspectors are not on board, and these happen when the inspectors is not seeing. So it's far from the inspector's eyes. And then this messes up everything from like logbook reporting to stock assessments, fair quotas, and even ecosystem health. Again, discards are the focus, but again, if you guys do find something related to this, maybe not discard focused, but similar, we would also entertain anything. It's okay. So yeah, why current tools fall short? One, because the tools right now show exactly where the vessels are and not what happens on deck. And that is why we've started EM to now see what happens on deck. Before, we used to have satellite that could just track vessel movement and the AIS, but you just know what happens, and then you probably have like the earlier forms of an algorithm that tells you that, okay, if a boat is traveling at this particular speed and has a bunch of patterns, it's probably fishing. But we could never see what happened on deck unless you had like an observer program, or if you had like an inspector on board. And having inspections at sea are pretty rare, like super costly and also unsafe. And the trend of misreporting in logbook has also risen, and we're not able to trust logbook and also self-reporting, because I assume it's part of their livelihood. They do want to make a quick buck. So if they would have to underreport some set of fish, it's an easy option. They would probably choose that. And this got us thinking, and we were like, okay, so since we have decided to put cameras on board and also have AI on board with a bunch of sensors, this leads us to an opportunity where we can now integrate all of these systems together and finally detect, like we would have sensors that detect hauling and sorting events. We would have cameras that look at catch composition, the sizes of fish, the species, to check if any fish have been discarded. And then we could integrate all of this to actually come up with some sort of solution. But again, it's also important to note that you would not be able to look at any of the video footage because of the rules and regulations, the GDPR rules. We would not be allowed to share. I think only enforcement would be able to look at it. But research has also proven that you could use synthetic and curated data sets. It's not that hard to create. We have a bunch of data sets that you could already use. Yeah, I will also put the links of these papers down in the chat in a while, and you can go through it. It's a good read if you're interested. But yeah, as I was saying, so this gives us an opportunity to build something that we can use to solve an issue. But again, I think a lot of people would ask, like, okay, cool, this is a whole completely unrelated topic, but where does space come in? And in our minds, we decided to use the Sentinel-1 or 2 Copernicus AIS together to look at vessel tracking, and also in the context of where exactly have they been doing this fishing? Is it near MPAs, protected areas? Is it near nursery grounds? What sort of conditions were there at that moment when the discards could have happened? Is there a particular spot that they would probably choose to discard? Is it like, how would you have to find, like, what are the parameters, or what are the factors that make discards desirable in that particular area? So you could use Copernicus and satellite data, to actually check how this whole thing comes together. And now if you could combine that with the EM outputs that the EM AI outputs that we would have, I think we have a very nice solution at hand already. And this would exactly tell us where discards have happened. And if you come up with another idea, maybe that as well. So yeah, our challenge right now is focused on discards. We would have you to combine like the satellite data with the synthetic onboard outputs that we have. And you could then look at how discards take place, and is it going to be per haul or like per fishing trip? What are high-risk vessels? Like, why are these high-risk vessels? Like, what are the factors that make them high-risk vessels? And I think this automatically aids in decision-making for monitoring as well as inspection. Again, as I have said, you definitely will not have any access to video. You could Google a bunch of it and maybe look at it online if there are images, but generally you wouldn't get, because like when you collect data on someone's vessel, it rightfully belongs to them, and they wouldn't want that data to be shared with anyone else. And even if you do have the masking and the blurring of faces, it still is a big risk, and there's a whole bunch of forms that you would have to sign. So let's just work with synthetic onboard data. So yeah, this comes to something that we like to call Blue Watch AI, where we use the vessel tracking system, the AI cameras on board with Copernicus. You combine it, integrate it together to give us a dashboard which shows where discards take place, and like a risk score as well. Yeah, the name is just something we came up with. You can choose, maybe come up with something more catchy, up to you. But Blue Watch AI sounds good. So yeah, this is a decision support tool that will combine all of these together, focus on discards, the high-risk vessels, the trips, the areas, the possible environmental conditions in that area, and eventually support decisions for monitoring and inspection. And I also think that you guys would ask for maybe more practical examples. There have been a lot of practical examples. Been a lot of primitive ones as well, like primitive in the sense compared to EM, like this example that I have in the slide right now. This is something similar to what we're looking at, but it's much before EM has actually begun. And then to actually move forward, a lot of other countries have already done a lot of EM work. They've put cameras on board, and they are looking at discards with a similar system that we are doing. This, for example, is from Denmark, where they actually have digital cameras on board and a bunch of gear sensors with the receiver and the control center, and they collect all of this data, process it, and then they're able to actually check discards. They look at false positives, see how it goes. They're able to look at species, the length of species as well. So projects like this have been done, and it is very successful. A lot of countries have been doing it for quite a while, and they've also moved on to edge computing on board, so that just the event is identified, and maybe the inspector could then look at it. So there have been a lot of practical examples, but the one we are trying right now, including Copernicus, is something new, and it sort of is a very broad idea. So it sort of includes a whole bunch of concepts. Like for us, it's not just looking at inspection, but we're also looking at like biodiversity monitoring at the same time. It's not just compliance monitoring. It's a whole broader circle. Yeah, as I said, you would get the synthetic data with like trip IDs, haul time, positions, the kilograms of the catch, the percentage of discards, and I think I have about 150 data points for you. you could create a lot more with the 150. So yeah, it's up to you to decide how much data is the right amount of data. I've just given you the base amount and also maybe a bunch of areas. And if you also do need to look at MPAs, it is available online, but I could also process that and send it over. Something that should be done easy. And yeah, this should together lead you to build maybe a map, maybe a dashboard, or maybe something more innovative that you think is nice. And you could have a simple risk score logic like discard rates from EMAI. What are the sensitive areas? Is there a season? What sort of fish is being discarded? Why? When is it happening? And is it happening like in closed areas or not? But also, I think you've heard me say a lot about like compliance monitoring. But again, the benefit, like I talk about compliance monitoring because from my work perspective, it is important, yes. But again, the person who benefits the most from these kind of programs and these kind of projects and this pitch as well are the fishers. One, because it opens the door for more informed fishing. So I feel that if you have more information at hand, you're less likely to commit more crimes because you have the information. Like there is no need for you to underreport in a logbook. There is no need for you to discard because you have informed fisheries. You can see what is happening. Like we're also looking at having cameras in net, which go down and give you live footage of what the fisherman is going to catch. And now the fisherman can decide like, I like this, I'm going to catch this. And if he decides, I don't, he's just not going to fish. So there is no concept of him catching that and then be like, screw the landing obligation and throw it back over. Like, no, this is informed fishery. So fishers are one of the biggest benefiters of this project. Then we also have environment and science because, informed fisheries is mainly based for science, universities, and the environment. And eventually control authorities like us, we just want to keep an eye, make sure that everything is being followed the way it's supposed to follow, have fairer enforcement programs and inspections. And eventually we feel that this will lead to broader support for water quality and pollution monitoring challenges. And at the same time, this type of pitch that we have right now with discards is a trending topic. A lot of PhD research is going on. And also it can inform future PhD research. For example, there are a bunch of students at Radboud who are interested in data flow systems. So concepts like these aid future PhD research as well. Yeah, I think that is it from my side. Any questions? I'm going to stop sharing my screen now.
Thanks very much. Yeah, any questions? Don't be shy. So open up the mic and just ask.
Yeah.
I think people need a little bit more time to think. So let me ask you the first question then. And thanks for the presentation. I see this like you have the vessel, which is a platform which is used for observations. Not only the platform itself is being observed, but also the vessel is being can serve as an observation platform. So, given the context of Cassini, there's elements of Earth observation, remote sensing. You mentioned IAS. There's of course elements for navigation. Of course, the jamming and the spoofing. I think, which is also part of your wish to find a solution for this, or at least to get an insight in the spoofing.
Yeah.
Because where fishermen can fish and where the fish is, this is not necessarily the same spot. So how does it appeal to these kind of economic questions, let's say, for fishermen?
Exactly. Yeah, that's right.
So is there any service or any is it also in this dashboard which you want to do, or in the monitoring part, or is it more like only from the remote sensing point of view?
we are open to anything at the moment. It's sort of like an open challenge. Like we put Discharges because it is something that we are focusing on. But again, you could build something which still makes sense and it's completely fine. Yeah.
So that's free for the participants to
for sure
to find out. Okay.
Yeah, because I will also be there on the weekends for the hackathon. Definitely could provide mentorship in terms of integration with like different systems and how an EM system works if anyone is interested. There's quite a lot happening, so could connect then as well.
Okay, good. Then anyone from the audience wanted to ask something? If not, then it must be absolutely clear. So thank you very much for your contribution. We can share the slides, is that possible?
Yeah.
Okay,
for sure.
so people will be informed. Yeah, you mentioned already the Copernicus Marine Services, which is also, I think, a relevant source of information. And also, there are two large projects regarding this topic, I would say, funded by the European Commission. One is, I think the most relevant is Iliad, which developed digital twins for marine applications, which might also provide some good insights in the challenges and the solutions which are about to be developed. Okay, Dakshin, thanks very much for your contribution. Thanks again. And then we quickly move on. So may I give the floor to Luca then?
Yes, thank you.
Luca, the floor is yours.
Yes. So I hope the presentation is already visible.
It is.
I'm trying to move this away. Okay, perfect. So hello, everybody. My name is Luca. I'm a scientific software engineer from S&T, and today I will present the project MestMonitor, which is a project which S&T participated, I think, until last year, and basically explored a specific case of pollution in the water. S&T, for who doesn't know, basically does, works on data and mostly into space and into environment, and gives insights from mostly from satellite data, transforms those images into insights. Regarding the presentation for my webinar, so the problem is that in 2018 there was a silo that got broken in the Belgium area and released manure into the Kuil, which is a river in the Limburg area. So the Waterschap Limburg then reported that there were many dead fish, and suggested that it was not good to use the water for animals or for swimming. And there was no way to discover basically which silos could have contributed to this, and there was a need for a better solution. So the main idea here is kind of simple, and is basically about using Earth observation to identify the possible risk objects, or at least structures that could have contributed to this pollution into the water. Basically, what we do is we use high-resolution images to to monitor and collect the silos, like to categorize the silos that then they can they can basically contribute to the pollution to the fuel that they could have contributed to the pollution to the fuel, and the area affected is highlighted on the orange the orange highlighted area on the right image. And for this we built MestMonitor, which as I already anticipated, it helps by mapping relevant objects and also to estimate the risks. It involves 3 different data collection rounds, or 3 campaigns, and then it gives geospatial outputs, and in the end, it also has an AI baseline that helped to contribute to this. The 3 monitoring rounds or 3 campaigns that have been done, basically they've been done in different period of time, and they involved different type of data, all of them in very high resolution. So we have the first one, which is the Pleiades Neo, which has a resolution of 30 centimeters per pixel, and it has been the first source in the beginning. Then in September, due to some unavailability for Pleiades Neo, the team moved to the BG3 and N3, which is basically same. I mean, it has still a high resolution, which is still 30 centimeters, but it's slightly different, which is not so bad because then we moved the model from working only on one type of data to two different type of data, making it more flexible and able to generalize. And this helped also to identify and reclassify some of the categories that were found. And then the last campaign was done on the same type of data, and helped as well for like to improve the results a little bit more and to finalize the categories and conclude the project. Basically, the data processing or the workflow, how it works, is basically that each image has been manually reviewed in the beginning for relevant objects, because of course there was no public data set, and it needed an initial imagery. So after obtaining the image from the Pleiades Neo, those images have been manually reviewed to detect where possible silos or possible other manure storage could be. And those were verified then with Google Street View and aerial photos from 2023 and 2021, and also with previous satellite images to check that those were structures and were not moving or possible false positive. Then it has been built kind of risk factor, which considers the distance from the waterways and the goal, and this results in exactly in a risk factor. And then once we obtained enough labeled data, or at least an acceptable amount, those were used also to train a machine learning model, which could help to better classify and to make this process faster. And finally, there is I mean, the results are reported and delivered in a GIS format, which is Geographic Information Systems and include coordinates. Some of the object detected or that have been also manually labeled are, for example, large open silos, which can be seen in those two pictures. Small open silos, which are quite small and are particular, should be these. Then there are closed silos. There are manure bags, which it's this one. And there are manure basins, which are a bit, they look like pools, but they have some greens on top. And then there are other cases which are mostly false positive, and they are for example, like training areas for horses, or they can be just food for animals, or just cleaning establishments. And all of these are categorized into the other. In the end, each campaign was helping to kind of readjust the number and confirm how many large open silos there were and small open silos. So basically, each campaign is applied after the other one and helped to better refine the label that we obtained. And after that, there was also, I mean, we were able at some point to train the machine learning model, which is a faster RCNN, which performs both classification and segmentation. For who doesn't know, the classification in simple word is, kind of classifying what is the object, so which categories it belongs. And the segmentation is detecting the amount of pixels that belong to the, in this case, to the silo, but to the specific category that we are looking for. Considering the data were not enough, an additional step of augmentation was done, which is a very simple step of rotation and flipping. And finally, just like to get better results, the best way was to only use large open silos because they are bigger and they are a bit easier to detect. And thanks to these steps or to these adjustments, the performance moved from the first campaign, which was to 0.4 mean average precision, to 0.6 for the second and the third, with slight improvement that are not on the mean average precision. Then, the main requirement for this will be that it will be required to have more images because of, for example, for large silos, they were only around, in the end, they were only around 24 cases, so which is still not a big number. But this will be the best to improve the model, but still 0.6 with so little was a decent result. And in addition to this, so not to basically after we found or after all the kind of possible risk factor were identified, there was the need to also give them a risk value. So they've been grouped into 5 categories that goes from very low to very high risk. And this is only considering kind of the distance from the waterway and to the hill. So it doesn't include any slope or construction quality, or if there is any shield that is applied or anything to avoid that, that any manure leak could reach the water. So it's only considering the distance mostly. But this already helps and kind of gives a good overview on which silos could contribute mostly to basically reach that they could have reached the goal during that event on 2018. The main risk function or the risk kind of function loss for the risk is basically 0.9 times the distance to the nearest waterway, which are highlighted in dark blue, and plus 0.1 times the distance to the hill, which is the light blue line. And so going to what the project can prove is that it shows already that the GIS, so that the geographic information system outputs can and a simple risk scoring can already make results already like quite useful because they help to organize the detection and they support prioritization. So basically to know where to focus or where to go to look for. It shows that AI can contribute because of course it can help to review different areas and in a way faster way. Even if you get false positive, they are still you have less spots or less areas to see rather than checking a full map. And finally, it still shows that for some cases where the context matters, and especially when the objects are very similar, the manual interpretation still is essential, and there is need for an expert or for manual labeling. And finally, what the project delivered is basically that it was possible to create a monitoring system that can be repeated on different campaigns on new upcoming data, and it can be also applied on new areas. and it's able to identify and review potential manure-related areas. And then, in addition to this, it just created a first AI baseline for silos detection, so which is quite helpful already because of the limited amount of data and no data set available for this topic. I think this one will conclude my presentation. So there is, I have a slide if you for questions. So I hope, first of all, that everything was clear, and I will be present on Friday on Friday and Saturday to the hackathon. So also there I will be helpful. But if there are any questions, feel free to ask.
Thanks very much. So, any questions? There's always a question.
Yeah, I have a question.
Go ahead.
I'm an inspector on nutrient standards. And how could we apply this in the future with inspections on the ground, on the level of companies? That's my curiosity. That's why I'm here. That might be a bit far away still, but how do you see that process?
You mean that, I mean, the thing of identifying the silos, or to understand which silos could have affected the pollution?
Yeah, well, we are mainly inspecting if there is overuse of manure. So if there is contamination with manure, and yeah, how could this kind of technology help us with the inspections in the future?
Well, in this case, it was mostly to identify the manure silos or manure concentration and where they are stored, so that basically, at least we were interested into the river, into the hill. So you have an interest area, and then you can consider a distance from there and kind of check those locations. But here, I think it's very. I think the topic is very specific because it affects only a river. So I'm not sure how to help on that, like on a very generic.
Yes, of course. Well, it's maybe too specific what I'm asking about, but another question is: did you take in account that normally a lot of manure is stored in the basement?
No.
Maybe not as much in silos. Well, of course, also a lot in silos, but if we do inspections, most the biggest quantities are in the basement of where the animals are, where the cows are. Those are the biggest content of manure. Did you also looked at that once?
No, because of yeah. Sorry.
Or only in the silos?
No, only on silos, or at least only on what is visible from satellites. So that can be observed, from which is basically what is visible outside of buildings, or it's not covered.
Okay. Yeah. Thank you.
No problem. Thanks for your questions.
Any other questions? If not, Luca, I would like to ask the following. You measured, of course, the concentration of pollution in the Gul. Of course, this pollution goes somewhere. So is it? Did you also think, maybe not on this project, about what happens with the areas where this polluted water heads to, and maybe some measures could be taken?
I mean, containment is always difficult in these situations, always, because when you discover it, I think it's kind of late, because you just, at least when when this happened, the river was also almost, I think I've read in articles that kind of 5% of the animals were left in that river. So there is not, yeah, I'm not sure how to still out, in a way, how to move after that, because that's, I think that when it's visible, or at least if it's, when the water is already polluted, it's kind of late, and you can of course stop the propagation of it, but I'm not an expert on the field, on the way on how to preserve water or how to save it.
It's also a bit of an inspiration for participants, so to provide a bit of a follow-up context. So
yeah, I mean, no, indeed, but there are different things that we can think about, and not sure if we can still do it from satellites, but yeah.
I'm definitely not the expert. I was thinking maybe there's a relationship between the turbidity of the water or algae development because of the nutrients which are there, which shouldn't be in it or something. But I'm definitely not the expert there. I'm only thinking out loud.
Yeah, yeah. I'm also not an expert on the water
Good.
field.
Then let's leave this for the participants. Okay. Any other questions from the audience? Then, if no other questions are there, then looking forward to see you at the hackathon, Luca. You bring a colleague as well, which I learned, which is great. And then we move on to the next speaker, Lianne.
Yes.
So we're a bit ahead of schedule, so you can have a few minutes more, which is I think nice. So if you can share your screen, then the floor is yours.
Yes. Let me... Certainly, I'm not allowed to share anymore. So
You're not allowed to share.
no.
Okay. Let's see. Maybe then let's go to Mattijs then, and then we solve this. So we have a few minutes to organize. Yeah. I can start it. Mattijs, are you able to share your screen?
Yep, I think so. I'll try that. Sorry.
Is it working? I see myself now multiple times.
Oh, all right. Then do it much better, I think. Well. No, why doesn't that work?
Okay.
Yeah, maybe when sharing, you should choose not the entire screen, but like the presentation.
Okay, that will work now, I think.
Yes, it works.
Okay.
Yeah,
It
just
works? Right.
yeah,
Great.
if you can just click on the slideshow so we can see the full slide.
Oh, I see it on the whole screen, but you don't. Right. That's. You see it now? No.
No, at the moment there is no screen sharing at all.
All right. Like this now? Not.
And now I have like just a preview of the whole presentation, but not in a slideshow mode. Maybe
No.
maybe
I
have a
don't do it.
maybe divide between the screens or
Yeah, I think so. Well, Lilian, if you if your works, then well, at least we have some moment then.
yeah, otherwise if you have this slides shared with us already, we can probably demonstrate them from our screen.
I have them on screen, so shall I share the screen?
Yeah, it's fine. Why doesn't it work? It just worked just now. Strange.
It happens.
It's technology. So okay, we go to the stress indicator. Okay, someone is sharing. Yes. And then in presenter mode, and then it should work. Yeah. Perfect.
Yeah, now it works.
It works now?
Yeah.
All right.
Yeah.
Okay. Well, sorry for that. No, my name is Mattijs Erberveld. I work at Rijkswaterstaat, which is in the Ministry of Infrastructure and Water. And I'm working on an innovation part of that, looking at the whole of our water and road. So we develop of the waterways and the road ways, and we are looking at the ecological parts of it. And one of that part is that we have monitoring on yearly based. A lot of yearly based monitoring is in all kind of reports, but what's the hackathon question is to make a daily monitoring form. And one of the ideas is to take a tree. So that is where I'm focusing on this few minutes, to build a dashboard which can indicate if a tree has stress. So the challenge is to go from an annual to a daily base, and to make a stress indicator. And of course, it is a basis for expansion to all kind of dashboards, which you give a better indication of the of how the ecological parts of our grounds are doing it. In the presentation you get sent it to, there is some more information about the cause. So it's linked to the Environmental and Planning Act, and it's linked to the Forest Monitoring Framework, and also to the Nature Restriction Law. So that are the cause why we would like to go to a more dashboard, more on a daily basis. So how can you monitor a tree? The data is not always on daily basis. Some you have only in a week or in a month. And how can you combine them to say something about the stress factor of a tree on a daily basis? So what are the stress factors? Of course, the water management, the location and soil, the nutrition, and the climate and weather are all part of it. What are the consequences of stress? Well, limited growth development, reduced the growth, increasingly pests and fungi, bacteria, and the reduction of carbon uptake. So that is all consequences of stress, which are nice to know if you want to know how your trees and how your environment is doing. So this all kind which you can think as data building blocks which are available. Sun, is it heat, is it cold? And all that times together you can make a stress factor. There is a lot of data, also from the European, but this is mostly yearly base or monthly base. So you have to think of a smart combination of all kind of data to make a daily base of. And of course, this is one of the possible approach. You collect available data, then determine in a scale of high stress, low stress, and bring them together. And maybe you can give a color or a picture of it, or visualize it on a map. So you can see, well, maybe how your garden is going to do the next week, or the ecological parts of it. Well, it is, of course, input for action. If we have a high stress expression, it could give attention to maybe is there a high way of fire chance, or is there another chance? Should we do something about the water points of that? And it can also be an indicator if it is a stressful year of the trees, or it is a very nice, unstressful year for a tree. So that's about it. I think it gives lots of things to look at, and you can when it is successful, you can have an indicator of is this stressful today or tomorrow by looking at it. So for now.
Thank you. Thank you very much, Mattijs. Any questions? No hands raised. So slides will be distributed afterwards. I just one question to ask. Like we speak about satellite data, which can be used, of course, that all kind of indices are developed to determine the health of trees and of vegetation. Anything you can share with us about the use of drones, for example, as observation platforms, and especially the integration from the satellite data with the drone data? Is it being used right now?
Well, the first step is, of course, at least that's where we think is have an indication of the stress, and when it's very stressful, we think it is possible to find on some areas where the stressful is highest, and then of course we would like to focus on that and bring it in more detailed information on it, and then drones could be a very useful component to focus on the specific areas where we expect the most of stress in that.
Good. Yeah, because although it's a Cassini challenge, it doesn't mean that you only need to focus on satellite data. Satellite data is important, but if you look at the full remote sensing column, anything which is relevant from in situ to geostationary can be used. So don't forget to do this during the hackathon.
No, that's great. Yep, good point.
Okay, Mattijs, thanks very much for your contribution. And then we switch back again to Lianne, who is the last speaker of today.
Yes.
So, yeah, all right.
You're seeing my full screen now?
No, it's not in presenter mode. So if you could.
And I think I have to share a different.
I can share it as well if you want me to.
Yeah, it's because I have to work in the browser, so that's a bit. I can share my full screen, perhaps.
Now it's in full screen.
Great. Good afternoon, everyone. I'm Lianne Wilmink. I'm from the Dutch Ministry of Infrastructure and Water Management, just like Mattijs, but from the policy part, so from the Director General of Water and Soil Affairs. And today I want to challenge you about a thermal challenge, because I want to help you manage our cooling water discharges in the Dutch rivers. So we have quite a challenge with climate change. It's making our waters warmer, and industrial cooling water discharges are an additional challenge adding to that. So we have a concern about the impact these discharges have on biodiversity and the surrounding environment. We want to know, can remote sensing help us understand these effects better? Currently, we lack a clear view about the cumulative impact these individual discharges have on the environment, and also on a national scale. So we want to see what's the impact on the environment, on the water, on the nature around it, because the Water Framework Directive sets a hard limit on water temperature, but it doesn't show us the impact as a whole. So even if we stay in the limits, we still want to know more about new risks and new developments in this area. Because rising water temperature is causing a ripple effect, because if water temperatures rise, we have less oxygen in the water, and this triggers blue-green algae blooms, and they can be toxic. This disrupts also fish migration because of thermal barriers, and it damages biodiversity. So if water temperatures keep rising or rise in a specific area, it's bad for the environment and for the water and for the people living around it as well. What I would like to see is that we combine remote sensing with ground truth, so with in situ data. Just like explained in the earlier presentation, there's a lot of data available, and I would love to see that we use this in situ data with remote sensing data, so with satellite data. I have 3 ideas that I want to challenge you with. So can you build a prototype of a dynamic discharge indicator that combines real-time sensor data with satellite imagery, so that we can more influence the discharges more directly, because now they just get a permit, but can you change this on more real-time data? And can you create a hotspot map showing cumulative risk for policymakers? So what's the risk for the environment? Where's the risk the highest? And idea 3 is, can you fuse thermal data with ecological data to demonstrate the local impact on biodiversity? So really combining this data, the satellite data, with other data sources, and showing the impact on the environment, showing the impact in the area. We also have a question from the Atlas Leefomgeving. That's the Environmental Health Atlas in the Netherlands. And it offers a lot of information about the quality of the Dutch living environment. It focuses on environmental themes like air quality, water quality, safety, and if the idea is viable and can provide a good map or a good image, we would love to add it to the Atlas of the Leefomgeving as a new information source. So that would be a very good way also to show your product and to give it a national stage in the Netherlands. There are a lot of data sources available. We have space data, Sentinel data, Sentinel-2, but also Landsat with a lot of historical thermal data, so that we can see trends. There's also in situ data from Rijkswaterstaat, but also from the Dutch water authorities. And they give a very precise temperature and other indicators for water quality on a 10-minute interval. And there's also a lot of ecological and economic data from the Water Framework Directive, so about fish, about megafauna, but also from our National Statistics Agency on water usage and ecological value, and also data from soil health can be an important asset to this as well. And of course, there are also a lot of nature data sets that can be collected and that are available to use and combine in this challenge to give us new insights and see, well, what's the impact of these thermal discharges. So this was my pitch. I will also be present, I think on Friday, perhaps on Saturday, and a colleague of mine will also be there on Sunday. So we'll be there to answer your questions and help you out with this use case.
Thank you very much for your presentation. Any questions from the audience? Yeah, it's a bit of repetitive, but then I will ask you the first one. So to help participants a bit more, you mentioned some challenging things like impact on biodiversity. It's similar to something like climate change. Then when is it relevant for you? What kind of impact are you looking for to help participants a bit out? Is it like species? Is it in invasiveness of species? Is it like shrinking fish? Is it whatever?
It could indeed be declining fish populations, but also if you can see, for example, with more, if you can combine the more visual greenery around these waters from satellite imagery and see if they change after a lot of discharge, or if these discharges add to the already present risk of drought in the environment. That's also one of the things I would like to see, and I'm also curious about, because I don't know what the impact is in its totality. So I would really like to see if you can, by combining these several data sets, and if it can provide us with new insights as well. So I would love to be surprised with this as well, and see if we can. It might be agenda setting as well, if there are some really shocking or groundbreaking things that come out of this hackathon. That would be a wonderful thing to see as well.
Good. So it could also be the case that if we can generate, or if some identifiers could be generated or sorted out, which could be result in follow-up projects during the next period, during the period after the hackathon, would also be a positive outcome for you.
Yes, definitely. Yes.
Okay, good. All right. Then I hardly dare ask if there are any more questions from people joining. If not, then we still have one element to go, which is the 1-minute pitch. And I'm asking my colleague Kasia, who did register for this one? Because we had...
We had one person registered for the pitch through the registration form, and actually 2 people. One of them became a speaker of this webinar. And let me see, we have Jan Peter de Jong from NVWA, but I'm not sure if...
Yes, he's on screen, so Jan Peter is joining. So Jan Peter, the floor is yours for your 1-minute pitch. Which ideas which you wanted to share?
Yeah, well, I was basically participating because I was very interested in maybe possible ways how to detect the overuse of manure. That's my Of course, it's my work, my job. So yes, I'm working at the NVWA as an inspector on nutrient standards. What I'm really curious about is how this can actually be applied in practice. It's not that I have any idea about it. It was more that I was participating and I just wanted to give the reason in the pitch. So one of the questions is, how do you translate satellite signals into something that supports decisions, for example, as a trigger for inspections, and especially as a way to flag where reality might differ from reported data? Because then it could be valuable in practice. And what level of detail can actually be traced, like pollution signals? Are we talking mainly about regional patterns that we were seeing in the presentation about the silos? Or are the potentials to go down to farm or parcel level? Of course, that's what we need most in the kind of inspection that I do. Well, those are the remarks and observations and my questions.
Okay. Well, thanks very much for sharing. And I definitely am not going to answer the questions. I don't have the insights.
Yeah, maybe there were more questions than a pitch, but well, that's the reason I was participating. So I was curious about those things. Yeah.
No, so let me invite you to join the hackathon as a visitor or as a mentor. Eh? So then you can observe the teams working on solutions which might give an answer to your questions. And yeah, otherwise, if you don't have time, then there's of course the European pitching between the local winners, and we will of course disseminate results from the hackathon. So let me say that we will do the thinking for you on behalf of all the participants of the of the hackathon. But feel free to join and visit the hackathon, and then maybe some of the teams work on the challenge which was presented by Luca from S&T.
Okay, I might consider.
Okay, good. Does someone want to make some final comments or remarks? If that's not the case, then I thank you all for your participation and all the speakers for your presentations. We will share the slide decks with people who registered, not only those who joined, but registered. In the coming days, more information will be provided about the last minute details of the hackathon itself. So for now, thank you all. Don't forget to register for the next webinar on the 22nd of April. And hope to see you all around in Noordwijk on the 24th. So thanks for now, and feel free to reach out in case you might think of a question after the webinar. So thanks now, and see you in Noordwijk. Bye.
All right, thanks.
Bye.
Bye. Bye-bye.